Today we're going to talk about simplifying radicals. So you're going to learn how to simplify square and cube roots and how to solve a quadratic. This is a radical. The number under here we call a radicand. We call this an index. It tells us how many times you need to multiply a number by itself to get the number under the square root symbol. So if it was a 2, we wouldn't have anything. We just assume it's a square root, which is what we've been doing all year. And then a 3 would be a cube root, a 4th would be the 4th root, and so on and so forth. To simplify, we find the prime factors of a number underneath the radical sign. If it's a square root, we pull out groups of 2. If it's a cube root, we pull out groups of 3. So we've got these examples right here. So with 75, if I find my prime factors, and prime factors are numbers that can only be divided by 1 in itself, 5 is going to go into 75 15 times. Remember these factor trees from like 5th and 6th grade? 3 goes into 15 5 times. So the square root of 75 can be written as 3 times 5 times 5. Now think about this as Miss Craig's little jail. Okay? In order to escape my jail, you and your twin must go as ones. And what happens is a penalty for me letting you go is your souls become 1. So you lose half your soul and it becomes 1 to escape. So these twins escaped, they became 1, and it became 5 root 3. Now some of you might be able to recognize that 5 times 5 is 25, and the square root of 25 is indeed 5, which is why this becomes 5 root 3. If you have a hard time with your perfect squares, it's just as easy to break it down. So if we take 48, we can break it down into 4 and 12, and 12 breaks down to 4 and 3. I don't need to go any further. I've got these two 4s right here, so they can come out of my jail. So it's 4 times 4 times 3. They can come out of my jail and become 1. So it's 4 root 3. Now these two examples are a little bit different because I have the 4 in front. All that is multiplication. That's 4 times the square root of 120, just like the coefficient is from the variable. And we multiply there too. So let's break down 120. I'm going to break it down by 12 and 10. You could break it down differently, but you would still get the same results. 10 breaks down to 2 and 5. 12 breaks down to 4 and 3. And the 4 breaks down to 2 and 2. So if you were to multiply all those prime numbers together, you would get 120. So 4 times the square root of 2 times 2 times 2 times 3 times 5. So I'm going to take these two out, and their souls are going to become 1. So I get 2 times 4 times 2 times 3 times 5. Okay, so now last thing we do is just multiply. So we get 8 times the square root of 2 times 3 times 5 is 30. So it's 8 times the square root of 30. And we say that that is in simplest radical form. Okay. There's nothing that can be factored out. All of the prime factors are pulled out that are perfect squares. Okay. Here with 225, 25 goes in 9 times, and 9 is 3 times 3, and 25 is 5 times 5. So I get negative 3 times 3, square root of 3 times 3 times 5 times 5. That comes out and becomes 1. This comes out and becomes 1. So I get negative 3 times 3 times 5, which is negative 45. Now it's okay to have the negative on the outside of the square root, but if the negative had been inside, like the square root of negative 25, we say that there's no real solution. You're not ready for that in your math career yet. Now these are different because I have a 3, so I need groups of 3. 1,000 breaks down to 10 times 100. 100 breaks down to 10 times 10. So we get the cube root of 10 times 10 times 10. I need groups of 3 this time. It's a lower, more secure level of prison. And so I've got this group of 3. It's going to come out and become 1. So the cube root of 1,000 is just 10. Now, unlike the square root, it's okay to have a negative under the cube root. Okay? The reason being, a cube root is a number that you multiply by itself to give you that. So if I'm asking for the cube root of -1, that's -1 times -1 times -1. That will give me a negative number. -1 times -1 is 1, times -1 is -1. So this cube root of -1,000 is -10. More cube roots. If I break down 108, 108 is 9 times 12. 12 is 3 times 4, and 9 is 3 times 3. So the cube root of 108 can be written as the cube root of 3 times 3 times 3 times 4. This group of 3 is coming out and becoming 1, so we're getting 3 times the cube root of 4. If you don't have that little 3 right there to show that it is a cube root, then you're wrong because that's a square root. Okay. So, last example for cube roots, -6 times the cube root of -144. We've already said it's okay to have negative, so you can even look at it as taking out a -1. Okay. 144 breaks down to 12 and 12. 12 breaks down to 3 and 4 and 2 and 2, so we've got that twice. So 144 can be written as 2 times 2 times 2 times 2 times 3 times 3. So I'm going to pull out my 2's. So -6 times -1 times 2, and inside is 2 times 3 times 3. If I multiply that out, I get +12 times the cube root of 18. Now, we have been solving quadratics now for a couple weeks, and you've learned to do it by factoring, by graphing, and by the quadratic formula. When there is no b, seems to throw you guys off a little bit, and I always tell you it's 0. Well, when the equation is in that form where there's no b, x squared plus c equals 0, or ax squared plus c equals 0, we can actually solve by taking the square roots. And we do that by getting the x squared by itself and then taking the square root of both sides. So square roots have both a positive root and a negative root. Square root of 25 is 5 times 5, okay, or -5 times -5, so that's why it's both 5 and -5. Okay, so we're going to take the square root of both sides, so we're going to get x equal positive or -6. In this case, we're going to add 14 to both sides, and we're going to get 242. 2x squared equals that. I'm going to divide everything by 2, so x squared equals 121. I'm going to take the square root of both sides, so x is 11, but again, we can't forget the negative, so we can write it this way. We can write it this way. Doesn't matter. All right, so today you learned how to simplify square and cube roots and how to solve a simple quadratic, those where b is 0. Have a math-tastic day.